going to talk about Android application development fundamentals, and in the context of that, I'll try to limit how much code I'm showing you. I'm going to try to focus on concepts, lines and circles, simple stuff. So it should be graphical for the most part. So really quickly, what we're going to talk about is we're going to talk about 7 different things, 7 different parts, iterations. The first one is going to be about activities and Android UI. Then we're going to talk a little bit about intents and the navigation, etc. Then services that run in the background, content providers, lists and adapters, broadcast receivers, and finally the little app widgets that you see at the top of the screen. So that's basically, you know, the plan. So we're going to hit 7 different iterations. Now, I need a context for this, and you know, if I just talk about something that's abstract, you may not be able to relate to that. So the context for this is going to be an application that I use for learning purposes. It's called Yamba. It stands for Yet Another Microblogging App. It's basically a Twitter app. I just can't use the word Twitter. So what it is over the years I've used different example apps. I had the restaurant app, the golf score app, this or that. But then I settled on this app because it's something that is very, it's very comprehensive. So it basically points out all the key aspects of Android app development that I find significant in a very natural way. So that's the reason why I like it. And secondly, most of us understand how Twitter works. Even though you may not be using it, you understand that you can see what your friends are doing and you can post the status update. That's about it. Okay, very simple. Don't need to explain it too much. Let me show you this app in a nutshell. So I have it running here on my emulator, and it looks like this. And the source code for it and everything is available for free. I'll point out where later on. But basically, this is just a list of what my friends are doing. And keep in mind, we're testing this against not the real Twitter, but our controlled environment, because Twitter would really soon kick us out if we were doing what we're doing in a classroom. Developing this. So we actually have a controlled environment that runs at yamba.maracana.com. So it's basically adhering to the same Twitter API, but it's just our own private server, so we can, you know, keep it fairly open. Keep in mind that a lot of people, all the people reading my book, everyone knows the username and password, so it's very public. So there's a lot of people learning and posting stuff here, and also the occasional spammers trying to sell you insurance and whatnot. So just so you know, sometimes weird stuff shows up. So that's the app. Oh, one thing that I didn't show you in the app is the screen where we are going to post the update. So this is the screen here. Should be coming up. So this is the screen where I can post an update. And I can say hello from, what's the name of this room? No, probably. Emulator is very slow. Let me just, I'll say hello from Illinois. And I'll click on update. So, because I'm not typing that slow, it's really slow. So what it's doing right now, it's posting to the cloud, and hopefully it works out, we'll find out. But this is actually making a web service call as we speak. And at some point, it should tell us if it's succeeded or not. I'm at the mercy of the network connection and other things like that. So we'll find out shortly. In the meantime, what we're basically doing is we're building, we're going to build this app or design this app. And OK, so it says posted successfully. So I can verify that 2 ways. I can go to that website and refresh it, and I should say if that was posted, and there it is, right? And I can also go back here, click on refresh, and pull it from the cloud as well. And if everything's fine, it should show up somewhere here as well sometime soon. Again, it's taking a while, but there it is, right? So that's basically the nutshell of the app, right? So we're now designing it, and we're using a graphical language that sort of I came up with because one doesn't exist. So really quickly, this box, the dotted line, hopefully you guys can see it in the back, represents my app, or more specifically, application context. So in Android, an application is not much more than just a container for your components, right? So they're basically components. There are 4 components: activities, services, providers, and receivers. I'll walk you through all of those components. And your app is just basically a container for them. So the app itself is not that significant. The components are, right? So the application is just a loose collection of these components. That's what's kind of interesting about Android. You can quite easily move them around from one app to another and so forth. So one of the very first components that we're dealing with is something called an activity. An activity is roughly a screen, represents a single screen of your UI. So in my app, this would be one activity, for example, right, where I see the list of my friends. This would be another activity that I can basically use to post something or update my status. So this entire screen is my activity. So that's that here. And basically what it's going to do, it's going to make a web service call to Twitter service. So that's the picture of that activity. Now what's interesting about activity is that it has a very complex life cycle. And this is probably the most complex out of all the components. So I'm starting with activities because they're the easiest to understand. They're visual, right? The only visual component that we have. But the life cycle is rather complex. I'll walk you through this really quickly. So basically, at the beginning of the day, you click on, I want to start my application. You're not starting an application. You're starting an activity within that application, right? The application doesn't matter, remember? So you're starting an activity within that application. So you are usually here in the starting point. So your activity doesn't exist. Then what happens is you go through a number of so-called lifecycle methods or callback methods. Right? So the system is going to invoke these on a transition from starting to running. Right? So system is going to invoke those methods. What's important for you as a developer is that you do not control the state of your activity. You have no input in that. However, you do control what happens in a transition. So you can basically say, hey, en route from starting to running, I want to add some code in, for example, on create. That's usually one that you universally care about. So right now, your activity is in a visible state or so-called running state. What that really means is that it's on the screen interacting with the user. So you can only have one activity in this state at any point in time. Only one can be in focus, interacting with the user. At some point, user wants to jump to another screen. So what happens is your activity is going to go via on pause to a pause state. Then it's going to get through on stop, and out very quickly it's going to end up in a stop state. Okay? You can have many different activities in a stop state, right? You can think of them as basically a cache. They're just basically a bunch of activities are sitting right now, right there in your phone, in the background, in a quote-unquote background. So they're not visible, but they're live in memory. The reason why the system does this is because the step from cold starting an activity to bringing it to visible state is very expensive. There are lots of things that need to happen. You need to launch a new process, allocate memory, draw the UI. Lots of expensive, computationally expensive things need to happen. So as opposed to just throwing that away as soon as you leave the screen, the system keeps those activities in a stop state. So when you want to later on get back to the running state, these steps are much cheaper. This would be cents to $1 in terms of the actual execution time, because you already have it loaded in memory. You just need to redraw it on the screen. At some point, the system is going to decide that certain activities that are in stop state are to be destroyed, and it's just going to destroy it on its own. So this is also what's very interesting about Android is you don't have a quit button. I don't know if you noticed, but you can't quit an application, right? Unlike in your Microsoft Windows, when you're done with Word or Excel, you go and you close it. And the reason why you're doing that is because it takes a lot of resources, right? So you as a human are managing the memory of your machine. So Android team felt that machines should be managing the memory of the machine, right? So it's sort of, they chose the automatic versus the manual memory management. It's sort of like, you know, the argument for a stick shift versus automatic transmission, right? Yes, humans can do a better job, but is it really worth your time at the end of the day? And Android team felt it's not, so that's why there's no quit button. It's all done automatically. So that's really kind of like a high level of the activities there's so many layers of understanding this picture. I can spend probably half a day just on this and keep coming back to it. But I'll move on, and then later on, if you guys have questions, we can address it. I know most of you are not developers, and I don't want to spend a lot of time on the code. But in a nutshell, whenever you're developing something in Android, you basically extend something that already is given to you from the system, and then you keep overriding these methods. So this is my on create, on start, on stop, and so on, right? So remember how I said you do not control which state you're in, but you control these transitions. You fill in these blanks, right? So this is lines and circles, and this is what the code would look like, right? So basically, you would say, I want to override an on create, I want to override on start, et cetera, et cetera. And you get to provide some useful bits and tidbits inside of those functions. That's just kind of how code looks like in terms of the lifecycle methods. So those are the lifecycle methods that we just mentioned. So on create, on resume, on start, stop, destroy. So there are a handful of those for an activity, and it's one of the more complex ones. There's some other ones that are related to menu, etc., but are not as significant. Whenever you create one of these main components, you have to register it. And you register it in a manifest file. So each app has a single file called a manifest file. And this file is sort of the big picture of your entire application. It explains what the application has as components, what permissions it needs, etc., etc. So it's usually about 1 to 2 screens in length. I think we looked at it in this case. So for example, in Hello World, it may look like this. So basically, this is my manifest file, and it says, I got an application, and that application has a single activity inside of it, and this is the name of that activity. So it's XML. It's usually about 1 to 2 screen sizes, so not that big of a deal. But it's important that you have to register each application, each component. So now we have an activity, and we want to build some kind of user interface, right? So now in Android, there are 2 ways to build UI, not just one. So one way is to do it programmatically, right? So for example, I want to build this UI, right? So I have a couple of components here. I have the counter that's going to go down as I keep on typing. I have a button, right? And I have an area that I can type in, right? Roughly. So in Java, I could say button, my button equals new button, button.setText update, button.set color white, button dot, et cetera, et cetera. I can basically programmatically do it. Second way to do this is to do it in in XML. And let me show you really quickly what that would look like. But it's basically, so this would be my same screen done in XML. It's going to take a little while to open up just because the tool is slow. Let me see if I can show you like this. So there's my screen in XML. And what you notice here is that the tool is sort of like, it's kind of like the Dreamweaver, right, for HTML. You drag and drop bits and pieces, right? Like if I wanted to add, stars, I could just like add, the rating stars there or move it down. That sort of thing, right? If I wanted to add a picture of a guy, I can like add it there, etc. So basically, you have this like very easy drag and drop kind of environment, and that basically just generates some XML for you behind the scenes. So there are 2 approaches to building UI. And usually what we do is we start in XML to describe our UI, and then we go to Java and we explain what the UI does. So if there's a button, XML is really a good tool to say what the button looks like. It's white, it's big, it's round, that sort of thing. But it's not a good tool to say what the button does, right? So Java is really good to say what the button does. Open up a web service and post to Twitter. So that's kind of how we use the 2 different approaches to get the job done efficiently, right? So the point is that you have 2 different approaches to building a UI. The UI, just like in other languages, is based on layouts and components. This is pretty similar with Java's AWT and Swing, if anybody's familiar with that. But basically, you have, when it comes to building a UI, you have so-called containers, things that can contain other things, and then you have the widgets that are the final elements. So for example, on this screen, I have a container. This would be my big white box, right? And inside of that container, I have various components, component 1, component 2, and component 3, right? So these are final components. They don't contain anything else. That's basically the logic. For those of you who know design patterns, it's the composite pattern or composite. So that's basically lists. We call them layouts and views, just a different lingo for containers and components, but same thing fundamentally. So we're done with the first screen. We can post to Twitter. Now, what we don't have in the previous iteration is we don't have a way to specify username and password. It's hard-coded somewhere in the code. So the next iteration is to add yet another activity, so yet another screen. So we already have this one where I can post to Twitter, but I don't have a way to update my username and password, and also I need a way to store that username and password. Right? Now, I would also need something that glues these things together. So I'm going to create a main activity with an action bar that's going to provide for that navigation ability to jump here or ability to jump here. Okay? So what that looks like is basically, it basically looks like this, except this would be blank, right? Imagine that this is blank. So this would be my main activity where I have the button where I can click on this and jump to that guy. Right? So now this is that guy. Or I can go back and I can jump to this guy that we're yet to build. It's just hidden under menu preferences. So I can jump to this guy and I can update my username and password, and that's going to store it locally. Okay? So that's what we're building next. Now, to understand this jumping around, you need to understand something called intents. And it's something that's purpose-built for Android. So intents are basically events or messages. They provide a glue between this. Remember how we said everything is loosely coupled, these components, right? So intents provide for the glue between those components. So I'll give you an idea here what it does. So for example, imagine that I am in Gmail app, right? I'm reading my email. So I'm looking at my activity, my screen that lists my messages. And I see there's a message from you, right? So I click on that message. That sends an intent to open up yet another screen where I can view that particular message. Now, that message may say, oh, check out this news article. So I click on link, and that now goes to yet another app, web browser, and within that opens up the activity. So it sent another intent to do that. So I'm reading this web article, and what it says, oh, check out the video that goes with the article. So I click on that link, and that now opens up YouTube app, within which it opens up the activity for viewing the particular video. So basically, all along, what we've been using is we've been using the intents to basically jump from one activity to another, to another, to another. And user just completed a task. User doesn't really care, it jumped from an app to an app to an app to an app, right? Just like when you surf the web, you don't really care that you're jumping from a website to a website. You're just going from a web page to a web page, right? You can also go back, right? You can unroll this whole path. So that's called, those are intents, and that's called a task. Now, intents can be both implicit and explicit. And this is an interesting feature. So an explicit intent would be if I'm Gmail and looking at the list of messages, and I want to open up a particular message, I want to open it up with a specific activity. So I'm going to spell out the name of the activity that's going to use to be used to open this message, because it's something that's internal to Gmail. It's nobody else's business, right? Now, when I'm in this reading the email message, and I want to open up a web link, well, that's more of an implicit intent, because anyone capable of opening up a web link should be able to compete for that action, right? So the user may have the default web browser that comes with Android, but the user might have downloaded Firefox or Chrome, right? So they should have a right to say, hey, I can also handle that request. Just like on Windows, when you download the Chrome browser or Safari or Firefox, and you no longer use IE. So the same thing happens on Android. And that's what allows for basically having multiple web browsers or SMS clients or other apps of that nature on your device that can compete for the same user action. So intents are pretty powerful in terms of that. Intents can do a couple of things. They can start activities. So in this previous case, I only showed you how to start activities, but you can also use them to start, stop, and bind services or send broadcasts. So those are about a handful of things you can do with intents. Like I said, they can be explicit or implicit. I don't want to go too much into code, but explicit one would spell out the name of the class that it's going to. Implicit one would more use so-called action, something of that nature. But again, code is easy to figure out once you understand the lines and circles, so I'm going to keep that fairly light. Now, when you send an intent, somebody needs to intent filter for it. That's how somebody says, I am interested in that intent. It's by creating an intent filter. An intent filter is basically just a very simple XML. It says this something filters for an action with specific name. So if you have an intent for a specific name, like open up a web page, then whoever adds the intent filter that says I can open up a web page would get asked to compete for that action, and the user would ultimately choose Firefox or Chrome, right? So that's how that works. So now that we have intents, we need the action bar. And the action bar is basically this thing here, more specifically this thing that we have here. So it's got buttons that I can click on, for example, and complete some action. If the buttons don't fit on the menu here, they could go into the menu that you get under pressing the menu button, right? So that's the action bar. It used to be just the menu, but since API level 11, since Honeycomb, we expanded it to basically be a little more feature-rich. To enable it, to have the action bar, you have to have at least API level 11. You have to specify minimum SDK version, etc. So that's not as important, but as long as you guys know that that's available to you there. To add action items, just to kind of give you a flavor for it, it's basically just a little bit of XML. So if I want to add a action to save something, I would basically say I want to have an item that has certain ID, icon, title, and show if there's room with text. So that's basically going to add a little button there. So it's a couple of lines of XML code to add a button, right? Or in Ice Cream Sandwich, they take action bar one step further, so they actually allow for so-called split action bar. So for example, I have more buttons here. I have 4 in total, but they don't fit on my screen just because I'm on a small device. They're right now hidden under the menu button. So if I press the menu button, you can kind of see them emerge here, right? Now, on Ice Cream Sandwich, you can actually specify a so-called split menu. So basically, you can get another one of these at the bottom like that. So it's always on visible. So that's a new feature of Ice Cream Sandwich. But it's, again, part of the action bar. You can use the icon also for the navigation. So that app icon there could be added as a navigation. So in this case, it doesn't do much, but you could use this to mean, for example, clicking here goes to home, or something similar. Just like on a website, clicking on a logo typically takes you to the home page. So you can easily add that feature as well. So now that we have the action bar and the preferences, so far what we've built is we've built a way to specify username and password. So specify username and password, and then a status activity where you can update your status and you can ultimately update the Twitter service with your status. But you don't have a way of getting the data from the cloud. So what we're going to use for that is we're going to use a background service. So we're going to look at services now. And this service, its job is going to be to, in the background, occasionally go to the cloud, check if we have new tweets, and basically pull them down from the cloud. Right? It's pretty straightforward. So services are background processes. I put them under quotes because the word background means different things to different people. What I mean by background, I just mean you can't see it. I don't mean it's running on a separate thread or a process, right? Because by default, services are not running on the same thread or process. They're actually running on the same thread as your UI, and that's something to deal with. So let me explain the need for services. So for example, I want to build a music player. Let's imagine I'm building Pandora or something similar, right? So obviously, I need some kind of UI. I need a place to pick the station, give it thumbs up, thumbs down, fast forward, rewind, that kind of thing, right? So I need a UI. And I could play the music from this UI. That's not a big deal. The problem is that that UI, as you learned earlier with activities, can be wiped out by the system at any point in time. System feels that it needs more resources. It says, oh, here's a UI that is not visible. I'm going to just dispose of it, destroy it. So we do not want to own playing of the music there because it could be destroyed at any point in time. So what we do is we actually create a service that now runs in a background, and it owns the actual playing of the music. So the UI would simply start a service. As far as we're concerned, the UI can disappear. That's not a big deal. In the future, if the user wants to get back to it, we just get back to it and would use it to, for example, stop the service. Right? So the service now owns the actual playing of the music. So service has a much simpler life cycle than activity. So basically, initially it doesn't exist. You start it, it's running. You stop it, it gets destroyed. The point is that you as a developer control it much more so than the system. So the system is not going to randomly stop your service. It doesn't happen as much as it does with activities that are not visible. So that's a big difference. The service, just like activity, again, you start by subclassing something from the system and then overriding specific lifecycle methods, just like activity, just like we did with the activity. There's a different flavor of a service called intent service that does the work on a worker thread. In other words, it doesn't block your UI thread. So that's kind of the big difference between the two. But from programming standpoint, as opposed to on start command, you just use on handle intent. So that's about the only difference there is from code point of view. Service callbacks, we mentioned those, on create, start, and destroy that are significant. And similar ones for intent service, on create, on handle intent, and destroy. Again, I'll give you all the slides later on as well, so just so you guys know. Whenever you create one of these main building blocks, so activity, services, providers, receivers, you need to register them to tell your app, hey, I have this component, it's part of you now. And again, it's either a simple one-liner XML, or it could be as complex as a couple lines of XML that basically says this service is responding to the particular action here. Okay? So now that we have the service, we basically have a way to pull the data, but we're not doing much with that data. So what we would want to do is we would want to store this data somewhere. And to store the data, we would want probably a database, but we also want to abstract the type of a database we're using, and for that we're using something called content providers. So content providers are basically yet another one of those 4 main building blocks, and they're used to basically abstract the data, access to data. If you remember, for those of you who were in the previous talk and I talked about security, I said how each app is in its own sandbox. One app cannot see the data of another app, right? That's the basic of the security model in Android. But what if you do want to share the data, right? What if I'm walking down the beach and I snap a photo of my daughter playing with a camera app, but now I want that same picture, I want to email it to my parents, with a Gmail app, or I want to post it to Twitter or Facebook with respect, those apps, right? So I obviously want to share that data, right? So the content providers enable that. They're basically interface to data. So when it comes to data, there are only 4 things you can do to a data: insert, update, delete, and query, right? That's it. So that's exactly what the interface looks like. You have insert, update, delete, and query, and you're kind of piercing that security hole with those 4 APIs to allow access to data. The system uses content providers all the time. So for example, all the contacts are exposed as a content provider. All the media, like pictures, for example, or etc., are content providers. Settings, etc., etc. Just to kind of give you an example. So if I'm writing, if you're looking for the address book or contacts, you're not going to find one app, you're going to find 2 apps. Right? So basically, we have one app called Contacts that has the UI. So this would be the user interface, right? This is where you can see your people, right? But it doesn't have any data. If you look for the data, there's no data whatsoever in that app. There's another app that has no user interface. So there's nothing visual about it. It's going to be really hard for you to even notice you have it, but it's there, right? And it's got all the data. So this one basically just asks for data from that one. So what this loose structure allows for is that somebody could come along and build another address book. Like, for example, HTC does this. It builds sexier version of your default apps, right? The address book on HTC Sense looks much nicer. But it taps into the same data source. So you don't have to have multiple databases. You can also have you mashup of this data. So Facebook data and Twitter data and Google Plus data and your own people data can all be mashed up in sort of a holistic view of a person. So if I look at information about Bob, I know everything across all these different social media and so on. So that's possible because of this type of a loose architecture. Content providers have a very simple life cycle. You on create, then you use one of those 4 things you can do to a data, and then you on destroy it. This is the implementation. Now, the implementation of the content providers is probably the least fun out of all. There's just a lot of code, and you know, again, you start by subclassing the system content provider, but the code for implementing content provider is usually not that pretty. Now, luckily, as an app developer, usually are more on the using existing content provider side than creating your own. But just so you know, if you're creating your own, there's a little bit of a code involved. The callback methods we talked about on create, on insert, update, delete, and query. Registering a content provider, just like anything else, you got to register it with the manifest, with the Android manifest file. One thing that you also need to specify is an authority. That's kind of how it advertises itself on the system, so that other apps can find it. And there's a short list of predefined authorities for things that are already baked into the system, such as contacts, settings, media, storage, etc., so that you know how to look them up as an app developer. So now that we have the data, so we got the data from Twitter via service. The service stuffed it into a content provider. Behind the scenes, content provider happens to be storing it in a database, but we don't really care about that. For the rest of the system is agnostic to the actual storage, right? Now that we have the data, what we want to do is we want to build a way to see data. I want to finally see what my friends are up to. So we're going to add a so-called fragment here for timeline, and then when you click on it, it can show you the details of that particular message. So basically what we're working on now is, remember before I said, imagine that this is blank? Well, now imagine that it's no longer blank, right? So we are filling in this part. We're adding this list here. And more specifically, if I click on a specific item in a list, I can see the details of it, right? So that's what we're building. This is the details view. So one thing that I like introducing here is the lists and adapters. So we have the data on the device, and imagine that I'm building like Gmail app, right? So if you're like me, you may have maybe 10,000 email messages in your Gmail account. It's quite easy, right? Over the years and so on. So now we are connecting the data source of 10,000 something to a screen that can have 1, 2, let's say 10 items on it. So you see the problem. We have gigantic data source, very tiny little screen, and a slow network in between. So what's your algorithm going to look like? Are you going to go and pull all 10,000 and just render the 0.1% or something? Probably not, right? So you need some kind of intelligent way of doing that. And yes, you can build your own, but Android already provides something called adapters. And adapters are basically an intelligent way of connecting large amounts of data to a tiny little screen, and they're going to automatically figure out how to pull the next. So as you scroll, it's smooth, and reuse the objects in the view side, and basically make it really efficient and highly scalable, so that you can basically connect the tiny screen to any amount of data. So adapters do a pretty smart job about that. Another thing that I mentioned earlier is something called fragments. Fragments are relatively new, often misunderstood. They're only introduced in the tablet version of Android, the Honeycomb. So basically, so far you guys know about activities, right? So activity, like I said, is a screen. This is an activity. It's a details activity. It takes the entire screen. And if I go back, I go to another activity, it takes an entire screen, right? So that's fine if you're dealing with a tiny little screen, which phones had, but tablets don't, right? And big screen TVs have even more real estate to work with. So Android needed a way to figure out how do we create reusable components so that we can have a single application, one single application that's going to look fantastic on a tiny little phone, a tablet, and a big screen TV. And when I say it's going to look good, I don't mean it's just going to blow it up on a big screen TV, right? Or put it tiny in the top left corner. We don't want that either, right? So we want to intelligently do that. So fragments basically allow us to have a different scenarios. In other words, a reusable UI. So for example, in a case that you've seen so far, I had a main activity that had a timeline fragment. So this is the list of my people. Then you click on one, and it takes you to another activity where you can see the details. That's what you just saw previously. Okay? Now, if I'm running on if I have more real estate on a particular device, why not have main activity open this component and that component side by side on the same screen, right? So two different screens, same screen, but reusable components. This timeline fragment and this timeline fragment are identical, details. So they're reusable. So to illustrate that, let me, I'm going to just flip my device from portrait to landscape mode. So if I rotate it, I suddenly have more real estate space. And the app is going to take advantage of that. So you can basically see how I now have the same timeline list here, but details are no longer a separate screen to jump to, but I can basically click on this, and it's going to open it up here. Make sense? So I'm reusing all this UI, and the app is intelligently going to redraw itself depending on the type of a device that we're running. So it's a single app that should look good on any form factor, more or less. So those are fragments. That's exactly what I just told you about fragments. So they're pretty cool. A lot of people don't get them, but they can be very, very useful, especially as we're getting to bigger and bigger screen sizes. Loaders are basically an intelligent way to load data. So sometimes loading the data can take a while. Like if I'm loading from Twitter, I'm at the mercy of the network. So it could be that I have no network, in which case it may sit there for 30, 60 seconds until it times out, right? And all along, it could be blocking my user interface. So I would be impossible for me to even touch a button or something because it's still loading the data. So loaders are basically an intelligent way to do that asynchronously. Using a loaders, you basically have something called the loader manager, and enables you to do that. Now, all these features, loaders and fragments that I mentioned, they're relatively new. We did not have them prior to Honeycomb, so prior to API level 11, right? But as you guys may or may not know, in terms of the Android universe, about 2/3 of people are still running on Gingerbread or below. So lots of old devices. So presumably you want your app to run on a lot of different devices. The good thing is that these new features are available to older APIs via a compatibility library. So you can basically just throw in a little library into your app, and suddenly it's going to be available to older apps as well, older platforms as well. So it's, in other words, you're expanding the capability of older phones via a library. So that's a good thing. So our second last iteration is to basically add a broadcast receiver here to automatically start a service. So for example, when you boot up your phone, you don't have to remember to go and start your Facebook and remember to go and start your Twitter and your Gmail and so forth. They're automatically going to be cranking in the background, pulling the data. So by the time you open up the UI, you have the latest data. So that's an example or a case for broadcast receivers. So broadcast receivers are basically a dormant piece of code. So it's a piece of code you write that you register for some event that can happen in the future. You say, Android system, I care about some kind of event. It could be battery is running low and I want to turn off Wi-Fi and Bluetooth. It could be the boot is completed, I want to start some apps. SMS arrived. network is available, network is not available, etc., etc. So you basically register it for events. When those events happen, you get notified. So it's basically a publish-subscribe mechanism or observable pattern, for those of you who know patterns. So that's basically what broadcast receivers are. They're very simple to implement. So you basically extend the broadcast receiver, and you have a simple method that you implement called onReceive. And that's where your dormant code is. So that's the only method onReceive. And this is how you register it. So again, you can register it via a little bit of XML, or you can do it programmatically, which is just a little bit more code. So the final part of this picture of this project is to basically create an app widget. An app widget is the thing that, let me show you. It's this thing here. It doesn't live inside of your app. It ships with your app, but it runs in, I think I have it on one of the screens. Could be just low. I think it's in this one. It's right there. It's right there. So it runs as a, this is my little widget here that simply says this is the latest tweet, right? So it shows on the home screen, for instance. But the point about it is that it doesn't run inside of your app. It runs inside of another app as a guest. That's why I drew it here outside of the dotted line, right? So that's the app widget. And app widget is essentially implemented as a broadcast receiver. So it's very similar conceptually to a receiver. So basically, when there's some new information, it gets pinged, and then it gets to do something. There's an additional file, the metadata file, that comes with it that basically specifies its width, height, so width, height, and how frequently to update it. So basically what I'm saying is this widget is 1/4 units. There's a concept of a unit. You might have noticed when you use widgets. And somewhere it's defined. There's a number, what a unit is. I mean, you look it up. There's a table. And so that's why these numbers 72 and 294 came about. I calculated it based on some documentation. And then I say every 10 seconds, basically, please update it. This is just the code. I'm going to pass over that. So that's basically what the widget looks like at the end of the day. So essentially that's the whole story of building what I consider an average size Android app that is touching on activities, services, providers, receivers, and it's illustrating all the things that I consider significant in Android in terms of a standard app development, right? The code for it is available at GitHub Maracana Yamba, so you can download the entire code. It's also what I use for my book, Learning Android. So it's each iteration corresponds to a chapter, so it's very well explained. And I'm actually updating the book right now for Ice Cream Sandwich. So that's basically also an explanation of that. The slides for this are available at maracana.com. Just search for architecting Android apps, and you're going to find it. Cool. Thank you.